Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in this tutorial, we will be taking a look at how actual the DNS communication works. The DNS protocol, that is the domain name system, and as defined by the in the RFC 1034 and 1035, is what some consider one of the most important protocols in use by the internet. This is because DNS is the, you can say, as proverbial molasses that holds the bread together. In a nutshell, whatever you type in the web address such as http://www.google.com into your browser, a DNS request is made to a DNS server in order to find out the IP address that name resolves to. This is because routers and the devices that interconnect the internet do not understand google.com. They only understand IP addresses such as 74.125.95.103, and that's for Google. So if you go ahead and check over here, I'll just go ahead and show you. Instead of typing that, if you go ahead and type 74.125.95.103, let's see what happens. Because this is an IP address of google.com, and I don't know. Okay, my bad. If I just go ahead and show it out to you, perfect. It should actually open google.com, but let's check what's the problem over here. And yeah, whois counter JFK. So it should show me that this is the IP address of google.com. It's way too slow, I believe. Okay, yeah, perfect. As you can see, this is the IP address. The host is the same, and United States. And so whenever you go and type google.com, it will search which IP address is registered to google.com, and no matter what the name is, the name will not be similar for any kind of website. It may be like google.com, google.org or something like that, but no matter what happens, the name will not be the same, because the name goes ahead and provides the IP address a unique identification when the DNS tries to go ahead and gather any information related to that. That is the reason. Let me just start. Okay. So this is okay. So the routers understand only the IP address and not the actual name. And later on, the name which is registered under the IP address will get converted to the IP address, and the router will then be able to identify what exact the DNS is of an IP address. So DNS server itself works by storing a database of entries. This is called as resource records of IP addresses to DNS name mappings, communicating those resource records to clients and communicating those resource records to other DNS servers as well. The architecture of DNS servers throughout enterprises and the internet is something that can be a bit complicated. As a matter of fact, there are a number of books dedicated to DNS architecture. I will not cover the architectural aspects or even the different types of DNS traffic. You can review that various DNS traffics related to RFCs later on their own website. But we will be taking a look at the basic DNS transaction, and this is how it looks like. DNS client and the DNS query the response. So DNS functions in a query response type format. A client wishing to resolve a DNS name to an IP address sends a query to the DNS server, and the server sends the requested information in its response. From the client's perspective, only two packets that are seen are this query and response only. The scenario gets a bit more complicated or complex when you consider DNS recursion. Due to the hierarchical nature of the DNS structure of the internet, DNS servers need the ability to communicate with each other, and in order to go ahead and locate the answers for the queries submitted to the clients. After all, it might be fair expect our internal DNS servers to know the name to IP address mapping of our local intranet server, but we cannot expect it to know the IP address correlated with Dell or Google, because that would be illegal again. This is where the recursion comes into play. Recursion is when one DNS server queries another DNS server on behalf of a client who has made a request. Basically, this turns a DNS server into a client itself, as you can see in this system, this one perfectly. Okay, and spoofing DNS, there is more than one way to skin a cat totally, and there is definitely more than one method available for performing DNS spoofing. I will be using a technique called as DNS ID spoofing now. So, and before I proceed, as you can see, this is the local DNS server, this is the client, and this is the external DNS, and this is the attacker. So I will normally go ahead and relocate everything from over here in this way. So I will not directly send this to if it asks for Yahoo, I will not send it to Yahoo. I will send it to my own website, which is fake. The user will log in or do whatever he wants to, and I will get all the information there, and then I will redirect it to yahoo.com. The same way it works. I am the local DNS server, which is the attacker. A response query is sent, the query response comes back, and I send it back to the client. That's how it works. So there's more than one way, as I told you, and every DNS query can be modified or changed depending upon the tools that you have. Every DNS that is sent out over the network contains a uniquely generated identification number. That's purpose is to identify queries and response and tie them all together. This means that if our attacking computer can intercept a DNS query sent out from a target device, all we have to do is create a fake packet that contains that identification number in order for the packet to be accepted by that target. And I will complete this process by doing two steps with a single tool. First, I will ARP cache poison the target device to reroute its traffic through our attacking host so that we can intercept the DNS request. Then we will actually send the spoofed packet. The goal of this scenario is to get the users on the target network to visit our malicious website rather than the website they are attempting to access, as you can see over here in this figure. The DNS spoofing attack using the DNS ID spoofing method, there are very few different tools available over here in total. So there are different types of tools available can be used to perform DNS spoofing. I will be using the ItterCap, which has both Windows and Linux version, and it has a graphic user interface as well, so it will be easier for you to understand. And you can download ItterCap from its own website. I'll show you if you are using a Windows version. Probably not, because this tutorial is for Kali, but still, if you need some time, then you can go ahead and see at SourceForge website. And you can go and download the tar.gz if you're using it on Linux or something else, or Debian, something like that. And if it is for Windows, you can go and download it from over here. And it's not much of a big file, and these are the easy files, easy to use files, so you can download either of these. This is the latest one, and I believe it was updated long time ago. Yep, fine. The latest version for Linux is over here, which is 0.7.6, and for the Windows version it has 0.7.4. I believe the 7.6 version has not yet been updated for the Windows version. And there is one more reason why I use Linux rather than Windows. Okay, so you can download the ItterCap from there, and if you do a bit of research on the website, you will find that ItterCap has a great deal of functionality, and that is beyond DNS spoofing, and it is commonly used in many of the MITM attacks. So if you are installing ItterCap on a Windows machine, you will notice it has a great graphic user interface, which you can say as which works great. But for this tutorial, I will be using a command line interface, and prior to executing ItterCap, a bit of configuration is required, and ItterCap at its core is a packet sniffer which utilizes various plugins to do the various types of attacks it can perform. So you need to go ahead and configure it in different way every time you want to use different types of attacks. The DNS spoof plugin is that what we will be doing in the attack in this example. So we have to modify the configuration file associated with that plugin. On a Windows system, this can be located at C program files, ItterCap ng share letter.dns, and if you're using Windows at Kali Linux, you can find it at root/user, that user means usr /share /ItterCap /Itter.dns. And this file is fairly simple and contains the DNS records you wish to spoof. For our purpose, we would like to use any user attempting to go to yahoo.com to be redirected to the host on the local network. So we will be able to add the entry highlighted over here in this figure. As you can see, this is the IP address and this is the original yahoo.com. So every time the user tries to connect to this part, it will be redirected to us. That's how it will work. And these entries basically tell the DNS spoof plugin that when it sees a DNS query for yahoo.com, or let's say www.yahoo.com, for an 8-type resource record, it should supply the IP address 172.168.1.1.6.100 in response. In a realistic scenario, the device at 172.168.1.1.6.100 would be running from some form of web server software that would present the user with the fake website as well. So once the file is configured, we are free to execute the command string that will launch the attack. And the command string will use different types of options. So that would be it for this tutorial, and I will be continuing the same part in the next tutorial.